Here is another question. A proton which is moving with a speed of 1 into 10 power 7 meter per second passes through a 0.02 centimeter thick sheet of paper and emerges with a speed of 2 into 10 power 6 meter per second. Assuming uniform deceleration, find retardation and time taken to pass through the paper. Okay, so a proton which was initially moving with a speed of 1 into 10 power 7 meter per second, and this is really high speed. If I write this expression in simple numbers, so it is meter per second. So you can imagine that this is really high speed because some subatomic particles move at very high speeds. And it passes through a very thin sheet of paper which is just zero point 0.2 centimeter, and then it emerges from the other side with a speed 2 into 10 power 6. So it means its velocity is decreased after passing through that sheet of paper. And now we need to calculate retardation. So do you know what is retardation? Retardation means the decrease in the velocity, actually measure of decrease in the velocity, because now we can see initially the velocity was 1 into 10 power 7, but now it's 2 into 10 power 6 meter per second. So velocity is little bit decreased. So we need to find this decrease in the velocity, and if you know from the previous knowledge, this is actually the change in velocity, right? Because initially velocity was 10 power 7 and now it's 2 into 10 power 6. So there is a change, and this change is actually the decrease in velocity, and this change is actually acceleration. Or if the velocity is decreasing, we term it as deceleration. So whatever it is, actually acceleration, the change in velocity, and we have to calculate actually the acceleration. The retardation means the change in velocity. Actually, this change is associated with the decrease in velocity. So as usual, let's imagine the problem. If we have a proton here moving with a velocity 1 into 10 power 7 meter per second, and we call it Vi just for the reference, and then it hits this sheet of paper which is only 0.02 centimeter the thickness, although in the question they wrote it thick sheet of paper, but I think it's not that thick. We should call it a thin sheet of paper anyway. And after passing through this sheet, it comes out of the other side of the sheet, and now this is its final velocity after coming out of the sheet. And we know that initially the speed was higher and now the speed is reduced, and it is very acceptable because when it passes through the sheet, it must have interacted with the sheet and velocity is decreased. And now they told us to calculate the retardation or acceleration, because we can clearly see that velocity is changed after passing through this sheet of paper. Okay, so it's easy. If I do a rough calculation, I know acceleration is change in velocity. It means Vf minus Vi divided by T2 minus T1, or I can call it collectively as the interval or the time during which this change in the velocities occurred. I can calculate this acceleration, or it is retardation if you like to call it that way, or deceleration. I can calculate it very easily because I have Vf, I have Vi, but I don't know how much time it took for the particle from entering at this surface of the sheet and exiting at the other side of the sheet. So I need to know the time during which it crossed this thick or thin sheet of paper. So if I don't have this time, I can't calculate acceleration. So is there any other way to calculate acceleration or retardation or whatever? Okay, so they gave us a clue. They said that it went under uniform deceleration or acceleration. So acceleration was uniform. And if there is any motion where the acceleration is uniform, we know we can use equations of motions. We are very well familiar with these equations. So it means we can use them. So we don't have time, right? So we have to choose an equation which doesn't have time in it because we don't know. In fact, in the second part of this question, we have to calculate this time. So if we don't have time, so let's choose a equation which doesn't have time in it. So this has time, but this one doesn't need any time. Here S is the distance traveled. I don't know, most of the textbooks they write it the displacement or distance as S, so I am writing it as S. But I would prefer to write it as D because D is for distance, right? Anyway, I am just following the textbook notation. So S is the displacement, E is acceleration which we want to find, and we already know the final velocity, initial velocity, and this S is the displacement the proton traveled in passing through the sheet, and this displacement is 0.02 centimeter. So let's calculate the acceleration or retardation if you want to call it that way. Okay, so I have written the equation here because this equation doesn't need time to calculate acceleration. It only needs the displacement through which the particle moved, and then we need to know the final velocity, initial velocity, and we have all of these three parameters. So first thing first, I told you to examine the question, and if there is any non-standard unit, convert it to the standard SI unit. So I see this one is fine, meter per second. This velocity is also fine, meter per second, but the thickness of the sheet is given in centimeters. So we need to change it to meters because meter is the SI standard unit. So I can call it as S because this is the displacement through which the proton moved. So S is equal to 0.02 over 100 meters. So now I have converted it into meters. Everything else is fine. So let's put all the values. But before that, we need to rearrange the equation so that acceleration is on the left side and the rest of the quantities are on the right side just for convenience. So I can write it acceleration, and by the way, don't forget that this acceleration is actually the retardation. So it's the same thing, or deceleration. So A equals Vf squared minus Vi squared, and I can divide both sides of the equation with 2s. Remember, s is the distance through which the proton moved. And now I can put in the values into this expression to find the acceleration. So Vf is here. This is the velocity after emerging through the sheet. So it is 2 into 10 power 6 meter per second squared minus, and then initial velocity before entering the sheet is this 1 into 10 power 7 meter per second, and 2 into 0.02 over 100 meters. So I have a scientific calculator which can calculate this whole expression at once, and it is giving me the value negative 2.4. So if you want to be efficient in solving the numerical questions, I suggest you to understand your scientific calculator and find out all the functions and all the functions of the calculator to use it very efficiently, because I can evaluate this whole expression at once using my scientific calculator. It is just a simple scientific calculator. Into 10 power 17 meter per second squared. So this is acceleration or retardation or deceleration. So we can see that this is really a high value. It means that although at the beginning of the question I said that there is a little bit change in the velocity, it's not a little bit change. It's a big change in the velocity and this acceleration, and negative sign, of course, it is telling us that velocity is decreasing. If acceleration is positive, it means velocity is increasing. I mean the previous value is lower than the present value. Okay, so we have calculated the retardation. Then next is to calculate the time taken to pass through the sheet. Okay, so now it's time to calculate the time it took for the proton to pass through the paper. So once again we have the choice. We can use any of these equations because uniform acceleration is involved in this motion. So we can use any of these equations. So I can use the first one because this one, it involves t, which we want to calculate, and then the distance, which we already have, 0.02 centimeter. Of course we have to convert it to meters before we can plug in this value into this equation. But I will take this equation. It has time, it needs final velocity, initial velocity, and it needs acceleration as well, which we have calculated previously, the retardation, and we have this value right now. So believe me, using this equation will be much more convenient than using this equation, although you will get the same answer and it doesn't matter which equation you use, but I leave it to you. I am using this equation to find the time taken to pass through the paper. And later on, you can try this equation to calculate the time. And then you will thank me for this. That why, and you will know the reason why I am using this equation. So let's use it. So I am rewriting the second equation of motion. Vf equals Vi plus acceleration times the time. And I am interested in finding the time, so I will reverse the sides of the equation. At plus Vi is equal to Vf, then At equals Vf minus Vi. I am subtracting Vi from both sides of the equation, and then t, this is the time we want to find, is equal to Vf minus Vi over acceleration. And now let me put the values. I know Vf, final velocity, which is the velocity of the proton after passing through the paper, is 2 into 10 power 6 meter per second minus initial velocity, which is the velocity of the proton before entering the paper sheet, 1 into 10 power 7 meter per second divided by acceleration. So I will show you once again the value we calculated in the previous step. Here is the acceleration we have calculated, negative 2.4 10 power 17. So I will put this value here. So negative 2.4 into 10 power 17 meter per second squared. So I am very efficient with my calculator, and it is giving me the value 3.33 into 10 power negative 11 seconds. So can you imagine how small is this time? This time is very, very small. You even can't imagine that it. Of course we can understand this because the velocity of the proton was too much, very high. And if velocity is high, of course, it would take very short time to pass a thickness of 0.02 centimeter. So now we have calculated both quantities, acceleration, time. And by the way, you can try to get this time using this equation and let me know how you feel.